Hey students, what's going on? For our lesson today, we are going to be taking a look at the moon and how it rotates and revolves around the Earth and why it produces different phases based on its overall location as comparison to where the sun, the moon, and the Earth are all positioned. Stay tuned. So the moon has a very unique rotation as it revolves around the Earth, and it's actually classified as a synchronous rotation, which means as the Earth rotates, the moon also rotates at the same rate. So we have what's called a dark side of the moon, and we have a lit side of the moon. The lit side. So here is my diagram of the Earth, the moon, and all the sunlight coming in. And no matter where the moon is, half of the moon is always going to be lit up by the sun. Because the moon, much like the Earth, is a big sphere spinning out in space. So this half of the moon, which is a golf ball, is always getting light from the sun. So even as it moves over and around the Earth, it is always going to be half lit up by the sun. In the same way that the Earth has night and day depending on what side is facing the moon. But when we are standing on Earth, here's you by the way, that's you, northern hemisphere. The moon is going counterclockwise. So it's going to move in this direction here. The moon has one side that is getting light from the sun, and the other side is dark. So we have the near side of the moon, which is the part that's lit up that we see, but it also has the dark side of the moon. So as you can see by the diagram, if the sun is over here, and it's shining light in this direction, so in order to have a new moon or a full moon, the sun, the moon, and the Earth have to be in a straight line. In order for me to have my first quarter and third quarter moons, the sun, the Earth, and the moon have to be at a right angle. So I've got sun, Earth, moon, first quarter, or sun, Earth, moon, third quarter. So a fun fact about the moon. The moon is Earth's only permanent satellite, which means it's always constantly going around the Earth. It's the fifth largest natural satellite in our solar system. The number one biggest satellite is one of Jupiter's moons. So just to reflect back on our positioning of the moon, if this is you standing here on Earth and you look out and it's a new moon, you will see 0% of the lit side of the moon. If it's a full moon and you're standing here on the Earth, you will see the 50% of the moon that is lit up by the sun. And the far side of the moon, the dark side of the moon, will be facing away from you. For the first quarter, when you look up into the night sky, you will see that the right half of the moon is lit up if you're standing in the northern hemisphere. So you will see 25% of the moon that is lit up. Same thing will apply over here, where you'll see 25%, but you will see the left side of the moon. Galileo took a huge leap forward in astronomy during the first decade of the 1600s with the invention of the optical telescope. So something that's really interesting to consider is that the moon is Earth's only natural satellite. And every year it moves 3.8 centimeters away from the Earth as it rotates and revolves. So imagine if it's moving 3.8 centimeters away every year, How small will the moon look in our skies a million years from now? Or go back in the other direction to back when the dinosaurs ruled the earth. How much larger did the moon look in our sky when there was Tyrannosaurus rexes walking around? Students, thanks for tuning in today. Make sure you keep up to date with your Google Classroom and that you're checking in with your teachers, as well as our live schedule. To everybody else, thanks for watching. See you next time.